My name is Oskar, and I'm going to talk about declarative GTK programming with Haskell. And I see people have beers in their hands, so this should be easy, right? Okay, so what led me into this in the first place is a project called FASTCUT that I'm working on. So I do screencasts for Haskell in my free time. And I started like the biggest yolk shaving exercise ever, which is then to implement my own video editor for screencasts in Haskell. And this is a desktop GUI application which has these goals of being minimal, so kind of doing only screencast editing, but doing that really well. Very suited for my workflow. I want the application's kind of core logic to be pure. I want this to be portable so that it can run on Linux, Mac OS, Windows, perhaps. I want it to be kind of reasonably snappy. So I'm using a 4K screen at home, and like all the Electron apps are lagging, so I wanted to use something else. And eventually, I hope to make this open source. It's very bare bones right now and not really useful. So one day, perhaps. Yeah, so I started looking at GUI frameworks and Haskell and what you can do. And there's sort of the imperative camp. Those are the big names in GUI frameworks, and they have bindings, most of them in Haskell. But they're still very, imperative, not so Haskell-y in their way of building stuff. And then there's a bunch of declarative things like Reflex FRP. That's an FRP framework. That's more functional from the ground up. And there's a thing called Free Penny GUI as well, similar, I think. Or you could build something with PureScript or Elm or something, put that in a WebKit view or whatever. But all those are built on the web technology and might not be what I'm looking for. So I decided to go with GTK and see what happens. So if you look at GTK, it's very imperative in its nature. You create widgets like new this button, then you have a button, then you can set stuff on it, you can call methods on it, you can attach callbacks, which are like effectful event handlers. So yeah, not very Haskell-y. There is also a thing called GTK Builder and an application called Glade, and you can use this to construct this XML markup in a WYSIWYG editor, and then you can describe your UI declaratively. But the problem is that it only works for the first render of the UI. Like, you load this XML file, you get an UI, and then you have to be imperative again and like find all the buttons and attach all the handlers. So it's only the first render is declarative, then you're imperative. Two phases. But with GTK, you have CSS support in some limited way at least, and I find this very, very useful. I'm using this. And there's a thing called G-object introspection, and this is actually broader than GTK. It's building on the whole G-object framework, so there are other packages than GTK that uses this. But it's very, very useful, as we will see in a minute. So, Haskell and GTK. There's an old binding, or older, which is called GTK2HS, and I think this has been deprecated in favor of the next one, which is called Haskell GI. And this is mostly generated from those G-object introspection metadata files. So those files contain like all the objects that are available, all the classes, all their methods and properties and signals and so on. So they've been able to generate a lot of support for GTK and other things using this. And you can use a feature in GHC called overloaded labels to refer to methods, attributes, and signals. And I'm using this. You don't have to. If you're using an older version of the GHC, you might not be able to. So it's optional. Anyway, the Haskell GI framework contains a lot of packages where GI-GTK is one of them, and that's the bindings for GTK. That's what we're going to look at today. So this is Hello World with GI-GTK. We initialize GTK first. We create a window. We resize that window to 200 by 150 pixels. We say that in case this window is destroyed, we will quit the whole GTK loop. Then we create a button with a label, click me. So So here you see the label, the overloaded labels going on. That's the hash something thing of creating a label. Yeah, we attach a signal handler to the clicked signal. So if you click the button, we will set the button sensitivity to false, meaning that you can't click it again. And we'll set the label to thanks for clicking me. Finally, we will add that button to the window, show everything in the window, and start the main loop. So let's do a demo here. This is the only demo, and I've cheated by pre-starting the app. Let's see if I can find it. This is Hello World in GTK. Yeah. Let's see. Click me. Boom. Yeah. Cool, huh? Yeah. Amazing. This is the example you'll find in the README on GitHub for GIGK. Anyway, not very impressive. So we will look at something slightly larger to convince you this is useful. Let's say you wanted this reusable, editable list of names as sort of a component that you can reuse in your app. You can give it a list of names. Those names can be edited by the user. You will get back a widget that you can add to your GUI somewhere. So this could be a type signature for this. We create an IO ref of a list of text values. Those would be the names. And the implementation could look something like this. So we will create a list box widget. We will read the initial names from that IREF. So an IREF is like a mutable reference in Haskell. We will loop over all those names together with indices starting at 0. And inside that loop, we will create an entry for a text entry. That's the GTK entry for each name. And we will attach a signal handler on the changed signal, as you see there. If that text entry changes, we will atomically modify the IREF with a new list of names where the name at the given index is replaced by the new name. We will add the text entry to the list, so we will have a list of text entries in the end, and then return that list. This is quite fiddly and ugly, right? Anyway, we might use it like this. We create a new IREF with some names, call this function, editable names list, get back the list, add it to a window. But it has a quite significant problem. So we're using an IREF for the state. And we can't really know when something has changed in that IREF. We can only poll it or have something in this editable names list do other things based on stuff being updated. So we get a weird coupling going on here, or we don't have any visibility, or we can't really react to stuff being changed. So we will change this definition slightly to look like this. This type signature. We'll give it an initial list of names instead, and we will return a tuple of a widget and a channel of text values, or lists of text values. Right, so each time a name is changed, we will get a message sent on that channel so that we can react to it. And we change our definition, something like this. We create a new channel inside here. We create an internal IREF instead, which we won't expose. And then, in addition to atomically modifying that IREF, we will write the value back on the updates channel, and we will return the widget and the updates channel. Still very messy, and yeah, but at least we can, on the outside, fork a thread and listen to these, pull these messages from the channel and print the names if they've changed. Not very impressive. So this is a general problem by using this callback approach that I've experienced. This is probably true for many other GUI frameworks. I've seen the same problem in like JavaScript, UI programming. If you have a lot of callbacks and everything, you have IREFs in Haskell, and your state and logic is like all over the UI rendering code scattered. You can't really figure out what's going on. Like just in the hello world, we had a small state machine where like either it was not clicked and you could click it, and then it became clicked and you couldn't do anything else. It was like the terminal state, but that was kind of hard to see in that code. There's side effects all over the place, and everything is GTK code, so it's hard to test. And you have these two phases. You have the first construction, and then you have all the subsequent updates doing the mutation all over the place. So I'd like the GUI code to be a separate concern to the application code. I like it to be more declarative. I want to create a data structure saying this is my UI. And I want it to be more concise than what you just saw. Also, the core application code should be pure, if that is possible. I'd like to strive towards that. And yeah, conversely, decoupled from the GUI code. So let's go declarative instead. If we wanted to do declarative GTK, we might want to have declarative markup instead, where you have, say, a pure function from your state or your model to that markup data structure. I'd also like to have some kind of declarative event handling. So instead of using these weird concurrency primitives like channels and IO refs and stuff, I'd like to just say emit this event if the button was clicked. There is like a technical necessity of having something like a virtual DOM patching going on. How many here knows what a virtual DOM is and what it does? Okay, quite a bunch. So if we render by taking our state and having a function from state to markup, we can't really switch the whole GUI on each update. We need to calculate the minimal change of that GUI and just go in and make that change. Otherwise, if you have like a cursor in a text entry, or you have some scroll bar position state going on, then you lose that state each time the whole thing is re-rendered, and it gets like what's it called? It just everything disappears and comes back, and it might be a bit janky. So we'd like to do minimal updates, and we'd like to have a framework doing that for us. And that's basically what virtual DOM does in JavaScript and WebLand, but we'll need something like that. Finally, I'd like this to be not tied to any particular architecture or way of writing apps. So I don't want this to be, the framework for writing Elm apps or whatever. I just want this to be about the markup and the patching. Okay, so I started another Yawk shaving project, which is GI-GTK declarative. And this is a very thin layer on top of GI-GTK, which uses these overloaded labels and the type information that is available in those bindings to basically give automatic support for doing declarative GTK and having this patchable behavior instead. Also, it features a way to build markup using do notation, so you can put adjacent widgets together using a do expression. This isn't published yet. It's on GitHub, but it's not on Hackage, but probably will be soon. Okay, so let's look at how you do stuff with this. If you wanted to create a single widget that is a widget that doesn't have any children, you can use the widget function, and you'll give it a constructor like button or check button here, and a list of attributes, which is empty. Note here that these buttons and check buttons, those are the GTK definitions of those widgets. So I haven't been required to redefine all of GTK. That would be a nightmare. But I can reuse those widgets from underneath. You can create what's called a bin, which is a widget that contains a single child widget. So, oh, there's something missing here. Anyway, so some examples are expander and viewport and search bar. There should have been a code example there, but it's gone. Anyway, you can put more stuff in a bin by creating like an intermediate container and then putting stuff in that container. So containers are widgets that contain 0 or more child widgets. So in this library, first off, in GTK, if you have a list box, like in the first example, you could basically append any other widget to that list box, and it will be automatically wrapped in a list box row, kind of implicitly. I've taken the decision to make all of that explicit, so you have to create bins of list box rows first, and then you can put a widget inside that. So here we create a list box with 2 rows each having, one having a button, one having a check button. And similar, the box container needs box children, or using the box child function. Okay, and here you see the do notation going on as well. Finally, these things can have attributes. So a widget, a button can have a label here. A scrolled window might have a scroll bar policy for its horizontal scrolling, being automatic in this case. And a container, in this case a list box, having a selection mode of multiple. You can use the on attribute in this framework, or this library, I should say, to do event handling, or to emit events. So here we have a counter button that first constructs a message saying I have been clicked this many times, and then in the yellow part you'll see that we say that in case this button is clicked, then emit this button clicked event. And supposedly someone would be incrementing some counter elsewhere. You can also construct events using I/O, and this becomes necessary, as it stands right now at least, because you want to query the underlying GTK widget for its attributes and put that attribute or whatever value inside your event and emit that. So this is a simplified version of the on-m attribute signature that takes a signal proxy. That's one of those labels like clicked. It takes your handler, that's the yellow part, going from the specific widget to an I/O action of your specific event, giving you an attribute. And you can use this as the bottom example here. We have a color button, and in case the color is set, we will get the color button RGBA value, and then we will fmap over that I/O action the color change event. So we will emit a color change event carrying a color value. These markup things like widgets, bins, and containers, they all have functor instances. So you can use this instance to map one sort of event, one type of event, to another type of event. So let's say these two first definitions, button event, only having a button clicked constructor, and let's say we have some clicky button thing in a library somewhere else, taking a text value and returning a widget emitting button events. So let's say that's in a library somewhere else. We can control that. But we want our own events that can be either Inker or Decor, and we want to use this clicky button. So in the yellow part in the bottom, you see clicky button. We give it some label, and then we map its events using this funny dollar arrow thing, which is an fmap utility function. So we ignore the button click constructor. We just emit Decor and Inker events, respectively. And then you see in the type signature that this is a widget of my event now. This is very useful for combining things. Finally, there's support for adding CSS classes to your markup. So you can say that I want the big button class added to this widget. And then you'd have to set up CSS somehow outside. I'm using this heavily. OK, so we've seen the library part of this declarative thing. I've also started working on a kind of experimental application framework thing that I call blah 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 app simple. A lot of words. This is built on a state reducer architecture, similar to a framework called PATCHABLE in PureScript. I think this is also similar to what Elm was like before, or maybe now. I don't know. I don't really know Elm, so I hear it's hot still, so I don't know. Basically, you create a value of this data structure, which is your application. It's parameterized by the model and the event type of your application. And you provide an update function going from model to event to a new model and an I/O action, possibly returning a new event. So you don't have to return new events in your update function, but you can. You also have a view function that goes from model to widget of event. And finally, you have the possibility to provide inputs, which is a list of pipes producers that produce events. So if you have something external feeding into your application, like a clock or whatever, you can put it there. When you want to run this, your app, you use a run function, you give it a window title, optional window size, your application, your initial model value that you start off with, and then you have an IO action. So let's look at Hello World from before, but try to rewrite it using this app simple approach. This was what we had before, a bit messy. We'll instead use data structures. So our model is not clicked or clicked, and our event is only button clicked. The view function will pattern match on the current model, or current state if you like. If it's not clicked, then we will create a button that says click me and that has the event button clicked emitted. If it already is clicked, then it will not be sensitive and it will have another label. The update function doesn't really care about the current state. It just says that if the button is clicked, then we will be in the clicked state. When we run this, we provide our app and we start with not clicked. Okay, this Hello World would work just as the thing we saw before. We will also have a look at this editable names list, which was more complex in our the initial kind of imperative GTK version. This was what we had before. If you remember the abomination, we will use the same approach. So our data model is just a list of text values. The event that can happen is that a name changes at a specific index and with a new text value. The view function takes our model of names, creates a list box, zipping the render name entry function over the names and the indices that are possible. So the render name entry function is defined below, takes a name and an index, creates a list box row to be put in that list box, which carries a widget, which is a text entry, having that name as the text, and in case it changes, we will emit a name changed event with the index and that the current text value of the entry. So here we need to use that effectful event handling. The update function will, kind of as before, take the current state, the name changed event, and then we will use some same lens magic here to replace a specific index value in that list with a new name. We will also use the second thing in the tuple is an IO action. So here we will also do a side effect where we will print a new name and then return no new event, just to demonstrate that, and run it as before with an initial list of names. This will also work just as before, but nicer code, right? I wanted to kind of briefly just talk about the implementation. How many here knows Haskell, or for some definition of knowing Haskell? Yeah, okay, good. You might be able to follow along, I hope. So at the core of this thing is the PATCHABLE type class. So this describes a widget that can create itself, right? So given some declarative widget, that's the lowercase type widget. Given some declarative widget parameterized by E for some event, you can get an IO action that creates a GTK widget. Or you can patch an existing declarative widget with a new declarative widget. So like this is the UI we had before, this is the UI we have now, and then you can get a patch back. And a patch is either a modification, like taking underlying GTK widget and modifying that, returning IO, or a replacement, saying create this other widget and just throw away the old one. Or keep, which is do nothing. Okay, another very important thing is the ability to have different types of widgets contained in another widget. So if all these widgets had different types, we couldn't really compose them as children together. So we need this wrapper around widgets. And this is very similar to a thing in data dynamic, called dynamic, but it carries additional constraints that we need in this framework for it to work. So this is a particular thing that if you want to use something like dynamic, but you need to carry more constraints, you can use your own gadget. This is a gadget, by the way, like this too. So we carry any widget that has instances for these things like typeable, patchable, functor, and event source. And then we get back a widget where the type doesn't really reflect what the inner widget's type is. And with this, we can implement patchable for any widget. So here, creating a widget is just creating the underlying widget. Patching two unknown widgets, we have to pattern match on those widgets and their types. So we use scope type variables here to pull out T1 of E1 and T2 of E2. And then we can use the typeable type class to do eq_t, which is a way of comparing two types. We use type application here, by the way. That's the at T1 and at T2. So we compare the types at runtime, pattern match on the result. In case we get this just refl value back, that's like a witness saying that these types are equal. And then by pattern matching on that value, GC knows that in this branch of the case expression, they are equal. So we can pass them both to the patch method. In case they aren't equal, we'll replace the first one with the second one. OK, and this is from the documentation of typeable. The typeable class allows you to calculate like a concrete representation at runtime of type. So that's how we can compare them at runtime. There's another crucial thing going on, which is that these smart constructors, widgets, bin, and container, they can return their return types are polymorphic. So they can either return these kind of anonymously typed widget things or specific types. So here I'm using type annotations just to make it return me a widget of event. I don't care what kind of widget, just any widget. Or they can return specialized markup. So in this case, if you look in the bottom first, we're mapping the text row function over some text values, and we're putting them in a list box. And the list box requires each child to be a list box row. So you see in the top signature that the text row returned this quite complicated type markup of bin list box row widget of events of unit. It's pretty complicated, but this is the type that is inferred, and you usually don't have to deal with them. But just to give you a sense of what's going on. Finally, I want to give you a small experience report from the FASTCUT video editor project on using this technology. So I tried first doing the imperative approach, kind of as you saw with the editable list and hello world. Failed miserably, not good. Then I started building this declarative thing instead, and which allowed me to build stuff with data structures and pure functions instead. So I have quite complex timeline navigation going on in this video editor. Like you can use weird Vim bindings to move around and do stuff. Also, the timeline commands operate like you have a focus pointing to a specific place in your timeline, and you might say, delete this clip or split this sequence into two sequences and stuff like that. Very useful to have that as pure functions and data structures instead of messy GTK code. But I'm also dropping down to the imperative layer where it's needed, like setting up the window, specifically adding CSS files, some event listening stuff, some things that don't really fit into this declarative markup thing, like dialogues and prompts. I haven't figured out how to do that. And also I'm using like a custom application architecture. I'm not using that simple app thing. This is one view from the application, just to give you a sense of it. You don't have to read all of it. It's basically the thing you have seen during the talk, just to give you a sense of this is what I'm using. I've also been able to use property-based testing because I've used this declarative approach. So using Hedgehog, I can use property-based testing to find all kinds of bugs in this navigation and in these commands, as they're pure functions is really used to test amazing stuff. And to summarize all of this, I think that callback-centric programming of GUIs is really hard, and I rather have pure functions and data structures. and make rendering just a function from your data structures or your model to widgets. And you can do this with GTK using this library, but you should know that it's very experimental. I haven't really built anything large with this app simple thing, and I have done 0 benchmarking, so it might be horrible. But given this, I can say that FASTCUT has been really, really nice to build in this style, and I encourage you to check these things out. Yeah, that's it. Here are the slides and code examples if you want to see more, or come and ask me about stuff I can show you. I don't think I have time to show you the FASTCUT thing, but I can do off stage. Thank you.